Good morning, ma'am.
Good morning. Good morning. How was your CT1, all of you? How was the CT paper? Okay. So what will we do? We'll start today microcontroller 8051. We have left with some interfacing ICs, but that we will cover later on because when we'll start the programming of microcontroller, at least you can get time to practice. So shall we start now? I'll start sharing the screen. Yeah, can you see the screen?
Yes, ma'am. 8051 DIP pin assignments.
Yes, yes. So as I told you, we have left with some interfacing ICs with 8085. So what we will do, we will cover this programming instructions of 8051 so that you can get time to practice the programs of 8051 microcontroller. And then later on, we will cover those interfacing ICs. So as in first class, we have already discussed the difference between microcontroller and microprocessor. What is the difference between microcontroller and microprocessor? Microprocessor is not having its own input output devices and its own memory, but microcontroller, they have their own input output devices, input output ports rather we can say, and they have their memory, may be available in less quantity, but microcontroller includes all these features in one single chip. So in 8085 we have to interface the ICs, like for input output we have to interface 8255, for timer counter we have to interface 8254, and for other applications also we have to interface the ICs. But even we have to interface RAM, EPROM, but in microcontroller it is available inside the chip only. But the only thing is that because it is the limitation is that it is a 40 pin IC, and limitations is with the availability of the ports, availability of the memory capacity. Everything will be there, so you can implement a small project, but for bigger applications then you have to go for advanced microcontrollers. So when we talk about 8051 microcontroller, this is there in your syllabus. So as I told you that in first class also I have told you that microcontrollers we started with 8048. Then after 8048 there was 8049, which was just a replication of 8048. Only thing is that some memory capacity was enhanced in 8049. Then later on we have 8051 microcontroller. So difference between this 8048 and 8051 is that 8048 was having less instructions and less memory capacity compared to 8051 microcontroller. And 8051 microcontroller, if we write 0, then it is a 8051 family, 8051 family of microcontrollers. If you have inbuilt EPROM, then the number will be 8751 microcontroller. If you have 8051, then you do not have internal EPROM, but the family is 51, all the instruction sets are similar. So and another IC we have 8052. There is no difference between 8051 and 8052 as far as instructions are concerned, and as far as pin diagram is concerned. You can well easily replace 8051 with 8052 if you do not have available 8051 in market. The only difference is that 8051 is having 4K of EEPROM and 8052 is having 8K of EEPROM, and 8051 is having 128 bytes of RAM and 8052 is having 256 bytes of RAM. So memory capacity is just doubled, rest everything, all instructions, all ports, each and every pin configuration is similar to 8051 microcontroller. So suppose if you are writing program with 8051 microcontroller, and suppose if your program is exceeding 4K, just it is going till 5K memory capacity, then what you can do, you just have to replace 8051 with 8052 microcontroller IC. So these are the basic things about microprocessor microcontrollers. So when we will talk about 8051 microcontroller, whenever we will study the instructions or whenever we will study the programming, what we will do, we will just compare with 885. So you will able to remember it easily, that the programming, the instructions, when we compare to 885, then it will be easy for you to remember the instructions. So is the basic clear to you? Is it clear? Anybody?
Yes मैम, but बहुत ज़्यादा नहीं.
So we just talk about the difference between microprocessors and microcontrollers. And when we wanted to start with 8051, so we have seen that what are the previous microcontrollers available other than 8051. So we were having 8048 microcontroller. These are all Intel microcontrollers. So 8051 microcontroller, whenever we'll see the programming or whenever we'll see the architecture difference, we will compare with 885 microprocessor, so that it will be easy for you to remember. Understood? This
Yes ma'am.
much is understood? Okay. Then we'll see the features of this 8051 microcontroller. What you have internal 4 ports. Port 0, this is your port 0. It is 8-bit port. Then you have port 1. This is also 8-bit port. Then you have port 2. This is also 8-bit port. You have port 3. This is also 8-bit port. So 4 8-bit ports are there. And in 8085, when you connect 8255 ports are completely input or completely output, all 8 bits. But here in this case, you have each port pin can be assigned as input or output. So suppose if you want to assign port to bit 7 pin as input, you can assign port to bit 6 pin as output. So you can operate this bitwise. Single pin, single bit can be operated as an input and output. It is not necessary that if port 2 is the complete port should be input or complete port should be output. It is not necessary. Single bit can be, single port pin can be input or single port pin can be output. Then as I told you that it is having internal EEPROM of 4K. So 4 kilobytes EEPROM is available and 128 bytes of RAM is available inside. Then it is having interrupts also. It is having serial communication facility also. So, and it is having address lines and data lines also. So how do you see, like suppose if it is a 40 pin IC, you have ports also, you have address lines also, you have data lines also, then you must have control signals, you must have interrupts also. So it is not possible for a 40 pin chip that for each and every operation you should have different pin. Because if this is the case, then your IC will not be 40 pin IC, it will be then 80 pin IC. So to accommodate everything in 40 pin IC, some of the pins are given double operations, double functions. So port 0 is AD0 also, port 0 bit 1 is AD1 also, like that. And also here in port 2 you have higher order address lines, and also in port 3 you have some control signals like receive data, transmit data, interrupt pins, etc. So whenever you do operation, whenever the address is used, it is working as address lines. Whenever you work that as a input or output port, then the same pin is worked as input or output pin. So each majority of the pins are having double functions. This much is clear? Yeah, Abhay Mishra, please ask. Abhay has
Ma'am, it was by mistake. It was by mistake.
okay,
It was by mistake.
okay,
Sorry,
okay,
ma'am.
okay, no problem, no problem. So, did you understand this much? Is it clear that
Yes,
you have
ma'am.
4 ports, and each pin is having multiple operations, like 2 operations? Because if it is not the case, then the IC will not be 40 pin IC. It will be then 80 pin IC or more than 40 pin IC. So to accommodate everything in 40 pin package, majority of the pins are having double operations. So we will see, like whenever we'll see this the features of ports, the feature of memory, address lines, data lines, etc., then you will understand that how this is separated. So this is just a block diagram of inside blocks of 8051 microcontroller. In 8085 we have CPU, central processing unit, we have oscillator circuit, we have control bus also. Similarly, we have this data bus also. But in 8085 we do not have internal ROM or EPROM, internal RAM and timer counter internal, and input output ports and serial port internally. We have interrupt, but we do not have all these features, RAM, EPROM. But this is there in 8051 microcontroller. You have internal ROM, read-only memory or EPROM of 4 kilobytes, and you have internal RAM for temporary storage of your data. It is 128 bytes. Here you have 2 timers, timer 0 and timer 1. So these timers can be used as timer also. This timer can be used as counter also. So whenever we will see timer counter operation, that time we'll see the difference between timer, counter, and how it is worked as timer and how it is worked as counter. Then you have one serial port also. So it needs only one input line, transmitting line, and one receiving line. You have four input output ports as P0, P1, P2, and P3. All these ports are 8-bit ports, out of which P0 and P2 they form the 16-bit address. Because it is 4K, so you have 16-bit address. And you can connect the external EPROM also. Maximum memory capacity which you can use is 64K after connecting external EPROM. So I think this block is clear to you. When we'll see the operation of EA, we'll see the operation of PSE and etc. ALE, you know what is ALE is doing? ALE is doing the demultiplexing of lower order address bus. As in 8085 also it was doing the same job. Here also it is doing the same job, because you have here multiplexed data address lines AD0 to AD7. So these are demultiplexed with the help of ALE. So is this clear? Internal blocks, how, what are the features, what are the blocks inside the 8051 microcontroller? Is it clear? ROM, EPROM, it is having timers, 4 input output ports. Is it clear? Shall we proceed further? Sakshi or anybody? Nobody's voice is coming. Why? Is it clear? This much is clear? Abhay?
Ma'am,
Yeah. Sakshi, is it clear to you? Is it clear to all?
मैम मैं डिस्कनेक्ट हो गई
Yes, yes,
थी
I know.
मैम डिस्कनेक्ट हो गया था
Yes, yes, I know. So we were talking about these internal features of 8051, that it is having internal timers. Two timers are there, T0, T1. You have internal RAM of 128 bytes. You have internal ROM of 4 kilobytes. You have interrupts. Then oscillator circuit is there. Some control buses are there. You have four input output ports. You have serial port, and P0, P2 ports are used as address bus also. And ALE is doing the same job that it is. ALE is what ALE is doing. ALE is demultiplexing the lower order address
एड्रेस
bus.
फ्लैश इनेबल यस
Yeah,
मैम
yeah, it is demultiplexing the lower order address bus, as it is doing in 8085. The same job it is doing in 8051 also. So these are the internal blocks, internal features of microcontroller. When we will see each in detail, like when we'll see the timers, then we'll see the details about timers. What are they? How do they operate, etc. When we'll see the ports, we'll see how do they operate. We'll see in the serial interrupt, serial port also operation of. So this is the basic block of 8051 microcontroller. This much is clear. Is it clear?
यस मैम
Yeah. So we'll proceed further, and this is the detailed block diagram. Like you have port 0, port 1, all ports are latched. Latched means unless until you override the data on the port pin, the previous data is not changing. Hello? हाँ हाँ नमस्ते नमस्ते हाँ. So this is the detailed block diagram of 8051 microcontroller. You have RAM, you have 4 ports, EEPROM is there, accumulator is there, then there are 2 temporary registers, ALU is there, arithmetic logical unit, and the difference is that in 8051 8085 microprocessor, you were having registers as A register, B register, C register, D, E, H, L, etc. But here you do not have this type of registers. You have A register and you have, that is accumulator, and you have B register. Apart from this, you do not have D, E, H, L. Then what you have? You have registers of labeled as R0 to R7, like R0, R1, R2, R3, R4, R5, R6, and R7. And these registers are available in 4 banks. 4 banks means each bank is of R0 to R7, and each register is of 8-bit register. So all the banks, the register names are same, R0 to R7, but these are differentiated with the banks. Like you have 4 banks, RB0 to RB1, sorry, RB3. So RB0 is having 8 registers, R0 to R7. RB1 is having 8 registers, that is R0 to R7. RB2 is having 8 register, that is R0 to R7, and RB3 is also having 8 register, that is R0 to R7. So apart from accumulator and B register, how many registers are there altogether? Apart from accumulator and B register, anybody can answer?
मतलब एक रजिस्टर है और 4 बैंक में तो ये 28 रजिस्टर्स हो जाएंगे.
कितने हो जाएंगे? How many registers apart from accumulator and B registers? Can anybody tell me the number? Apart from your accumulator and B register, total how many registers would be there? Sakshi? You can write in chat box if your mic is not clear. So there will be 32 registers. 32 why? Because each bank is having 8 registers, R0 to R7. So likewise there are 4 banks. So 4 banks means how many registers should be there?
32.
Yes, 32. 4 into 8, 32 registers. So whenever we write R0, use R0 to R7, first we have to specify register bank. Then only the registers R0 to R7, they are referred to that particular bank, because they are not having numbers from R0 to R31. They are having numbers from R0 to R7. So it should be differentiated with the help of bank specifying. You have to specify the bank. And then again you have this interrupt serial control, the oscillator circuit, etc. This is the detailed block diagram of 8051 microcontroller. So like in 8085, the crystal frequency, internal operating frequency is how much of crystal frequency in 8085?
internally divided by 2 होती है.
Yes. So if you use the crystal of 2 megahertz, internal frequency will be 1 megahertz in 8085. But in 8051, it is divided by 12. You have each machine cycle. Yes. In 8051 microcontroller, your internal operating frequency is crystal frequency divided by 12. So if you use 12 megahertz crystal, then what will be the internal frequency? 1 megahertz. Yeah, because it is, and 8051, these microcontrollers, they operate on higher frequencies, not like 885 microprocessor. In 8051, you can use 12 megahertz crystal. So if you use 12 megahertz crystal, then your internal operating frequency will be 1 megahertz, because the circuitry is such that it is divided by 12 inside. In 8085, it was divided by 2. Here it is divided by 12. So this is clear. Operating frequency of 8051, it is divided by 12 inside. So we'll see some features of 8051 microcontroller. What are the features? Whatever we have talked till now, it is having internal ROM and RAM. It is having input output ports. Yes. Yes, please.
मैम एक आपकी क्रिस्टल फ्रीक्वेंसी 2 मेगाहर्ट्ज है, तो आपका जो टी है वो कितना होगा? तो फिर 1 होना चाहिए, 1 माइक्रोसेकंड। जैसे क्रिस्टल फ्रीक्वेंसी 2 मेगाहर्ट्ज दी गई थी, तो
हाँ, 2 megahertz if the crystal frequency. You are talking about 8085 or 8051? 8085 के बारे में, 8085 के बारे में बात कर रहे हो? You're talking about 8085 or 8051? See, in 8085, I think you got disconnected or what?
यस मैम, डिस्कनेक्ट हो गई थी। मैम ये बोल रही थी 85 में क्रिस्टल फ्रीक्वेंसी 2 मेगाहर्ट्ज है, अगर तो वो इंटरनली डिवाइडेड बाय 2 हो जाएगी, तो ऑपरेटिंग फ्रीक्वेंसी 1 मेगाहर्ट्ज हो गई। तो उसके लिए जो टी बनेगा वो तो 1 माइक्रोसेकंड होना चाहिए ना फिर?
यस यस।
बट मैम इस तरीके से तो सीटी के क्वेश्चन में अगर 1 माइक्रोसेकंड लगाया गया था, वो आंसर गलत था। वहां पर आंसर में अगर देखा गया तो वो 0.5 माइक्रोसेकंड आ रहा था। ये मुझे समझ नहीं आया।
अच्छा, I will see, I will check it, okay? And if it is so, then I will correct it. I will correct it.
Yes, ma'am.
I will see
दो क्वेश्चन थे, मैंने वही 1 by 2 करके लगाया।
हाँ।
Okay, ma'am.
I will see to it. I will see to it, and if any corrections, then I will give all of you the marks for that. Okay.
Okay, ma'am.
Yeah. So here it is divided by 12. Internally in 8051, it is divided by 12, because here you, and also here you operate on higher frequencies. So when you connect 12 megahertz crystal, then your internal frequency is 1 megahertz. So we were talking about the features. It is having internal ROM. It is having input output ports. 4 input output ports are there. Each port is of 8 bit. It is having 2 timers. They can be used as timer and counter. It is having serial data communication operation also. So we will see all this in detail also, timer, counters, etc. Then it is having 8-bit CPU with registers A, that is accumulator, and B register. Then it is having 16-bit program counter, because your address lines are 16 address lines. So 16 address lines, so it should have 16-bit program counter. And you have a 16-bit data pointer also. There is one more 16-bit register which is called as data pointer. Then you have 8-bit program status word. This was there in 8085 also. You have 8-bit stack pointer. In 8085, your stack pointer was 16-bit. But in 8051 microcontroller, your stack pointer is 8-bit. Why stack pointer is 8-bit over here? Because the internal RAM is of less capacity, 128 bytes only. So 128 bytes, because generally we assign the stack pointer in RAM location. And in 8085, you have 64 kilobytes of memory. So you can have 16-bit stack pointer. But Here, because your internal RAM is of 128 bytes, so you have only 8-bit stack pointer. So, program counter and data pointer, these are two 16-bit registers, rest all are 8-bit. Then you have internal ROM of 4K byte. You have internal RAM of 128 bytes. Then you have 4 register banks, each containing 8 registers, that is from R0 to R7, and 16 bytes which may be addressed. Out of these 32 registers, 16 by that means it is having 32 locations as registers, out of which 16 bytes may be addressed at bit level. Bit level means, suppose R0 register is bit addressable, then R0 register contains 8 bits. So these 8 bits can be addressed single bit as a single bit. That means you don't have to refer the whole register as R0. You can use a single bit of R0 register also. So likewise, how many bytes or how many registers are there which can be used as bit addressable area? It is 16 bytes. That means how many bits you are having bit addressable? How many bits are there which are bit addressable? Can anybody tell how many bits can be addressed at bit level? Sakshi? Kaushal?
मैम क्वेश्चन समझ नहीं आया.
If you have these are the 4 banks, and each bank is containing 8 registers, R0 to R7. So how many total registers are there? 32. That means register
Yes,
area
ma'am.
is 32 bytes. Out of these 32 bytes, your 16 bytes memory location of your RAM. Total RAM is 128 bytes. In 128 bytes, 32 are your registers. And apart from this 32, then remaining area is how much? Remaining registers?
96 bytes.
Yes, 96 bytes. So 96 out of this 96 bytes remaining area, your 16 bytes are bit addressable. Bit addressable means each byte is containing 8 bits. So these 8 bits can be addressed as a single bit. Each bit will have the address. So how many bits can be addressed? 16 bytes if you have as a bit address, a bit level of a bit addressable area, then how many area is there? How many bits are there which can be addressed? Is the question clear now?
128.
Yes. 16 into 8, that is 128. So that means 128 bits are available for you which you can address as a single bit. How we do that and what is the use of it, that we'll see when we'll see the programming or when we'll see the applications. So 32 bytes will go in registers, 16 bytes is going in bit addressable area, and remaining 80 bytes out of this 128 bytes RAM is available for general purpose, like you can write your program, you can use as a storage or etc. So this 80 bytes is general purpose memory location. So this is how your 120 bytes of RAM is divided. Then you have 32 input output pins. Why 32 input output pins? Because you have 4 8-bit ports. Understood?
Yes, ma'am.
Yeah. Then you have two timers, T0 and T1. They are 16-bit timers. So timer T0 is also 16-bit and timer T1 is also 16 bit. Then you
16 bit.
have, yes, then you have some special function registers, out of which there some are control registers also. What is these special registers they are doing? These special registers, they are for specific applications. Like suppose if you have to work with serial communication, then you will be using SBUF, serial buffer, as a register. If you are using timer counters, then you can use TCON TMOD registers. SCON is used with serial communication. TCON is for power control. IP and IE registers are for interrupt controls. So these are called as special function registers. We will see how many are there and what are they, and we will see that how they work whenever we'll see the individual operation. Like whenever we'll see timer counter, that time we'll study TCON TMOD. Whenever we will study serial data operation, that time we will study SCON SBUF. Right now I'm giving you the overall features or overall details of 8051 microcontroller. Then you have 5 interrupts. 2 external interrupts are there and 3 internal interrupts are there. In 8085 also you have 5 interrupts, but here 2 external are there and 3 internal are there. And you have oscillator and clock circuit. So this much is clear. The basic features are clear. Whatever we have discussed with block diagram, the same I have written here in point wise.
Yes, ma'am.
So same whatever I have discussed here, the same is been written. The same. Now suppose if you want to classify the microprocessor or microcontroller, then how do you do that? There are number of ways. Like you can classify based on bits of operation, like 8-bit microprocessor or 8-bit microcontroller, like that. So this is the one way of classification, that based on number of bits you can classify that this is 8-bit or 16-bit microcontroller. So 8051 is 8-bit microcontroller because it at a time it handles 8-bit data. Then you have classification as CISC or RISC processors. What is CISC and RISC processors? CISC means complex instruction set computers, and RISC means reduced instruction set computers. So complex means processor have large number of instructions. So large number of instructions, that means your programming, assembly language programming becomes easy because you have large number of instructions. But and in RISC processors, it is reduced instruction set. That means you have limited number of instructions. Like 8085, if you classify 8085 and 8051, then 8051 will come under CISC and 8085 will come under RISC processor. Why? Because 8085 is having limited number of, reduced number of instruction set, whereas your microcontroller is having more number of instructions. So based on this also you can classify as CISC, RISC. You can classify based on 8-bit, 16-bit, etc. So these are the ways of classification of microcontrollers or microprocessors. Yeah, meantime you go with this, whatever is written, then I will explain all these things.
मैम पीडीएफ शेयर कर दीजिएगा।
हाँ, यस। So in 8085, we have seen addressing modes as direct addressing, immediate addressing, register addressing, etc. Here also we have the same types of addressing modes: immediate, direct, register indirect, and indexed addressing mode. So what we'll do, we'll see the instructions, and then we'll see some this addressing modes also. So in 885 also we were having data transfer instructions. Here also we have data transfer instructions, but in 885 we were having A register, B register, C, D, E, etc. Here we have R0 to R7 registers, and we have A and B registers. So when we talk about data transfer, we have move instruction over here. So only move instructions are there in data transfer. In 885 you were having Alexa, etc. also, and in 885 you were having for immediate addressing MVI instruction was there, but in 8051 microcontroller MVI instruction is not there. It is move only. Even if it is immediate data moving, it is MOV. Even if it is not immediate data, then also it is MOV. But how do you differentiate between immediate data move and non-immediate data move? It is based on this hash sign. In 885 you do not write hash sign because you are writing MVIE, but here because you are writing MOV you are using hash sign. So hash means it is immediate data. So what are the instructions, categories of instructions? You have move A comma immediate data. So immediate data, 8-bit data can be moved in accumulator. Then you can move immediate data in any of the register. When I say RR, this R can be from 0 to 7. So you can move immediate data in R0, in R1, R2, R3, R4, R7, R0 to R7. When I write RP, that means it is for pair, register pair. And for register pair, only R0 and R1 registers are used. Sorry, not pair, RP, when just to differentiate between this RR and RP. Because when I write RR, then this can be R0 to R7. When I write RP, then this is only R0 and R1. This is clear? Whenever we will write RP, then RP can be only R0 and R1. And whenever we will write RR, then RR can be R0 to R7. So if I write move RR comma hash data, then how many instructions are such? How many instructions will be?
8.
8, yeah.
8 instruction.
Yes, good. Similarly, you can use 8-bit address. 8-bit address because you have 128 bytes of RAM. So you can use that address, 8-bit address directly over here, and you can move the data to that particular address. So not only A accumulator, not only RR, you can move the data into address also. Then you have you can move the data from any register to accumulator. You can move the data from any memory location to accumulator. You can move the data from accumulator to any register. You can move the data from any address to any register. Then you can move the data from any register to any address. Then you can move the data between two addresses, from one address to another address. And you can DPTR, because DPTR is 16-bit register. So here your data should be 16-bit data, because your DPTR register is 16-bit register. Then you can move the data. You can move the data from accumulator to address. Now we'll see what is this at sign. At means it is indirect. Indirect means, suppose if I write the instruction as move at RP comma some immediate data, then RP is referred only to R0 and R1. So suppose if my instruction is move at R0 comma hash data, then hash data is your immediate data, 8-bit data, where it will go. If this would have been R0, then it would have gone to R0. But this is at R0. At R0 means whatever is in there R0, to that particular memory location this data will go. That means, suppose if your R0 is containing 30 hex, then it will not go to R0, it will go to 30 hex. This immediate data will go to 30 hex memory location. If I write move R0 comma data, then data is going to R0 register. But if I write at R0, then the data will go to the memory location which is available in R0. Understood?
Yes, ma'am.
We will repeat this tomorrow also. We will repeat the instruction set tomorrow. You start writing your this attendance in chat box.
मैम अटेंडेंस लगभग सबकी हो चुकी
हाँ, okay. Then we'll stop here, and what we will do, we will I will share the PPTs. I will share this PDF. Prashant, please write your attendance as roll number and then name, because I save the data in that fashion. Prashant, why are you writing Prashant 34? You all have to write your roll number first, roll number and then. So shall we stop over here? If you have any problem till now, you can ask me.
मैम
Yes, please. So shall we end the meeting now?